So question 13 says, analyze the polynomial function x cubed plus 0.3 x squared minus 1.3677x minus this 0.38229. So has some strange little coefficients and constants. So determine the end behavior of the function. So again, the end behavior is going to be behaving like the leading constant, the leading term, I should say, which is the x cubed. So it's going to behave like an x cubed, a third degree polynomial. So notice how the leading coefficient's of 1. So based on what I'm picking up on, it's probably either going to be the first graph or the third graph because of end behavior. The only thing is I'm not sure about the zeros. So let's go ahead and graph this using the graphing utility. So y equals x cubed So a tough one to type in. So a graph kind of looks, it still kind of looks like both of those. So let's go ahead and change the window like they said. So -3 to 3 to 1, and then -2 to 2 to 1. The graph again. So yeah, it looks much more like the first graph. That was kind of what I was aiming for, but yeah, that kind of clarifies it. It definitely looks more like the first graph there. So use the graphing utility to approximate any x and y-intercepts on the graph. So the y-intercept, again, I don't know how to do that on the graph calculator except to maybe substitute 0 in for x. So y is going to equal this 0 cubed plus 0.3 times 0 squared minus this 1.3677 times 0 minus this 0.38229. Notice that when you multiply by 0, that's going to drop out, that's going to drop out, that's going to drop out. The only thing we're left with is the constant. So the y-intercept is really just going to be the constant. And they want us to round this to 5 decimal places. Well, luckily it's already 5 decimal places, so we're already there. So this negative 0.38229 would be the y-intercept. Now the x-intercepts are also called zeros. So let's see if we can find the zeros on this graph. So notice how it touches the x-axis here and the x-axis there. So I'm seeing there's actually 3 zeros. 1, 2, 3. So if I use my calculate button, use number 2, let's move over to the left side of the first x-intercept or 0, hit enter. So I got to go across there. There's a sign change, hit enter. And notice how the x-intercept is going to be in between those 2 lines. Hit enter again. So here they say round to 2 decimal places. So that's going to be negative 1.18 because that 2 just says keep the 8. So if we do the second calculate again, we have to be left, hit enter, and then to the right, hit enter. And notice that the x-intercept should be between those 2 lines, and it is. Hit enter again, and we end up with then another one would be negative 0.27, actually negative 0.28. So that 8 in the third place tells me to round that 7 up to an 8. So do this one more time, second calculate zeros. Again, we want to be left again. Notice that these are all crossing, so these are all a multiplicity of ones. And we did get a third zero, which is 1.16 if we round to 2 decimal places. So using the graphing utility to help complete the table here. So since these are integers already, we should be able to find those rather easily just in the table. So second table, if we go to -2, we're getting those values already. So they do want this 2 decimal places. So that's going to be -4.45. And then a -1 would give us 0.29. 0 would be -0.38. And then 1 would give us -0.45. And 2 would give us 6.08. So we don't have to just use the table there to complete those. So we just have to complete that table below. All righty. So next thing it says, approximate the turning points on the graph around the coordinates to 2 decimal places. So those turning points are also called max and mins. So if I go back to the graph, this is going to be a turning point here. So let's see if we can find that. That's going to be a maximum. So second, calculate number 4. So move my little spider guy. Got to be left of that turning point. Hit enter. I got to be right of that turning point for that maximum. Hit enter. Hit enter again, and that's going to be one of the turning points. So it looks like -0.78, 0.39. So it looks like this one is a turning point. So it looks like this other one's probably the turning point as well, based on what we're seeing. Let's just go ahead and double check it. Second, calculate. That's going to be a min. So this is number 3. So I need to be left of that turning point. Hit enter. Got to be right of that turning point, or that minimum. Hit enter again. And we did get 0.58, -0.88. So that does check out. So A and B both need to be selected since there are 2 turning points in that problem. So F says, use the information to draw and complete the graph of the function by hand. Well, I don't think we're really going to do this by hand. We're just going to basically pick up on this graph right here since they're giving us multiple choice. But if we graphed it by hand, we could be graphing those x-intercepts and those y-intercepts, and those turning points would be ways to sketch it by hand. So the domain of the function, notice again, there aren't any domain restrictions. So this is going to be -infinity to infinity. So there's no left bound, there's no right bound. The same with the range. Notice that it goes down and goes up. There is no absolute minimum or absolute maximum. So the range is also the same thing. It's all real numbers. So using the number notation there. So we want to use the graph to determine where the function is increasing and decreasing. Select all that apply. So on which intervals is the function increasing? Round the endpoints to 2 decimal places. So notice that it is increasing from like -infinity up to this turning point. And what was that x value at that spot? That was that -0.78. So -infinity to 0.78, it was increasing. Notice it was decreasing for a while, and then once it gets to this turning point, it went back up again. What was the x value there? That was that 0.58 at that spot. So 0.58 to infinity would be the other increasing interval. So that would be the other one here, would be that one. So select the intervals or interval where it's decreasing, round to 2 decimal points as necessary. So notice it's decreasing between this turning point and this turning point. So remember that x value was the negative 0.7, and this one was the positive 0.51. So yeah, that negative 0.78 to that 0.58, that's where the graph is actually decreasing. Okay, that was a big problem. So that was question number 13.